Alright, this is Chapter 9, Lesson 5. We're doing guided practice off of page 760. This is about the fundamental counting principle, which most of the time we just call the counting principle. It helps you find the number of outcomes without drawing a tree diagram or without making an organized list. If you're making a series of selections, then really all you need to do is take the number of choices times the number of choices times the number of choices for each selection. And that will give you the total number of outcomes. So for example, number 1 here says we're tossing a quarter, a dime, and a nickel. We want to know the total outcomes we can have for these 3 events. 3 events are happening. I'm tossing a quarter. Well, there are 2 possible outcomes for a quarter, heads or tails. 2 for a dime, heads or tails. 2 for a nickel, heads or tails, excuse me. The total number of outcomes is then 2 times 2 times 2. There would be 8 total outcomes. You could get a heads, 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 a heads, heads, tails, a heads, tails, heads, a heads, tails, tails. We could list all those 8. Okay. Second one, rolling a number cube, which number cube is what they generally call a die or dice, right? So there are 6 different possibilities for a number cube. And picking a cube from 4 different colored cubes. So 4 choices and 6 choices. 6 times 4, there would be 24 different outcomes. Because once again, you could roll a 1 and pick a blue. You could roll a 2 and pick a blue. 3 a blue. 4 blue, 5 blue, 6 blue. You might get a roll a 2 blue, 3 blue, 4 blue. And then we could go on to all those same things for red and green and yellow. 4 different outcomes. So number 3, they're asking how many outfits you could make if you had 3 sweaters to choose from, 4 blouses, and 6 skirts. Well, number of choices times number of choices times number of choices. So 3 times 4 is 12. 12 times 6 is 72. 72 different outfits, which are kind of like the outcomes of this. And so what is the probability that you randomly select an outfit? 1 out of 72. You have a 1/72nd chance, which is about somewhere around 1.4%. And that would be highly unlikely that you randomly select that one. And so implications of this are things like license tags. Let's say your license tag has to have, we're just going to make up an easy one, has to have 2 letters. That means there's 26 choices and 26 choices. Then it's going to have 4 numbers, 0 through 9. Well, that'd be 10 choices for each one. If you want to know how many different license tags you can make that have this system, 26 times 26 times 10 times 10 times 10 times 10 will get you the total number of outcomes. So you think about a password. If they have a 5 character password, if they all are numbers, right, then you would have 10, 10, 10, 10, 10. And sometimes they don't let you repeat a number, so then it'd be 10, 9, 8, 7, so on and so forth. Sometimes they say, well, you need to have letters. Well, then if you're going to do a letter password, then you have 26 choices, 26 choices, 26 choices, 26 choices. You can multiply all those, right? What if you changed this and said they can be capital or lowercase? That gives you 52 choices for each one. So you see why picking a password, it pays. And a lot of times sites will give you options like you have to have at least one capital letter, at least one special character, because now you're throwing in a whole bunch more if you can put in the @ sign or parentheses or a $sign, any of those different signs. You're not going to have 52. You'll have all sorts of possibilities. So sometimes you have to have numbers too. Well, that means if you can have characters or numbers or letters that are capital or lowercase, then think about how many you're getting there. You're getting 52 plus these 10 plus a whole bunch of different characters. So all of a sudden you might have up to 75 choices for every single possible thing. Does that make sense? And so to have a more secure password, you want more combinations of these letters and things. So rather than just having a 3-digit number passcode, which would only have 10 times 10 times 10, would only have 1,000 possibilities, we say let's have a lot of different things. And a lot of times they require you to have 8 characters or something like that, just so you can get number of choices times number of choices times number of choices, gives you the total number of possible outcomes.